discrete event simulation. This is really a tool that we can use to model integrated systems of quantum devices and components. And there have been a wide range of simulators, of discrete event simulators that have been developed for quantum networks, including Aliro simulator, NetSquid, Sequence, Quisp, and others. Now, what discrete event simulators really do is they combine the timing, the modeling of time and events with the evolution of quantum state. So typically in all of these quantum network discrete event simulators, we have both sort of quantum components such as photon sources, optical fibers, and photon detectors, which are integrated with a virtual timeline and a quantum circuit simulator that processes the quantum operations. And the way that this generally works is we don't model every point in time. We really just model a few discrete points in times at which significant events occur. So in this simple prepare a photon, send it through an optical fiber, and then detect it on the end example, we would have a source that might initiate this sequence of events by creating a state. And that state would be prepared by applying the X gate onto the 0 state to create a 1 state qubit. So once that state is prepared, it will schedule another event, which is emit. And emit will then pass the photon to the input of the optical fiber. Now the optical fiber will take some time for the photon to transit. So once input to the optical fiber, another event will be scheduled, which will be output the photon. Now, at that future point in time, the photon will have transited the fiber, and the discrete event simulation framework will be able to look back and know how long it took that photon to transit the fiber. It is then able to retroactively apply any of the noise that occurred during transit before outputting the photon. Now, one important thing to note is that all the noise was applied previously as the photon travels down the fiber, but really we can just pause time within our virtual time framework and apply all that noise in place. Once the noise has been applied, we can then pass the photon to the detector and we can begin our measurement event. And since measurement might take some amount of time in the real world, once we measure, which will take up some time, we then can output the result. So this is a way of how, or an example of how events get scheduled on the timeline and processed in order, leading to essentially a causal sequence of events that models a real-world quantum network. Now, discrete event simulators are really useful for things like designing protocols, doing feasibility assessments, or estimating metrics. And their main sort of claim to fame is that they're able to really accurately model the timing of events in a network in a very precise manner. And this is very important for understanding how systems integrate with each other.